Good morning, everybody. I think there are coming people in, but we will see that. So, welcome to AU. First session. It's my first AU, so it's my first session as well, so that's a bit strange to give the first session, but okay. My name is Josje Ruijs. I'm from the Netherlands. I work at the Royal Haskoning DHV, and I'm a BIM coordinator. I do large-scale projects all over the world. And today I'm going to talk about closed-loop lifecycle management in those projects. And I'm going to show you some few simple steps in the software to implement those ideas of CL2M. So yeah, I want to keep it practical. So the first part is in the first part, I'm going to tell you what CL2M actually is and why we want to use it and in what kind of projects we can use it. And after that, I will show you in the same time what the importance is of real-time data, for example, in the projects. And then I'm going to tell you how you can implement it in the software we all are using now, and with simple steps so we can implement it. So one of the parts is a part in Civil3D, so we're going to look at corridor solids, and then we're going to link all the stuff together in Navisworks, and we're going to link databases to it. So closed-loop lifecycle management. What is it? Closed-loop lifecycle management is a derivative from PDM and PLM. So when PDM started, it was product data management, so it was all about the product and all the information that was in that product. But it was really product-based. And then they introduced product lifecycle management, so the whole lifecycle and the management of it was implemented for your product. And now we are going a step further, and we are going to closed-loop lifecycle management, where we are adding feedback loops. So all the data we have, we are going through this life cycle, but in all various steps of those life cycles, we have different data we could use. So with the whole march of the Internet of Things, we get more data from everywhere, and we want to see that in our whole life cycle. So we want to have a loop back, for example, to our design. But I can tell you all of this in some boring slides, but I actually made you a whole world. So I made a micro world for you, and here I'm gonna show you the principles of CL2M. So we have this nice world, and we have a road. It goes up the mountain, but here we have a tunnel, and then we have a bridge we have to build, but there's no bridge. So if we are going to see where we start with our life cycle, we go to our extraction. So we need resources. So here our life cycle starts. So we have an extraction, and these raw materials we have to process. So that is our industry. So our second step is industry, and it's not. I will tell you in a second, but it's the start of the life cycle, but maybe not the life cycle of our designs. So I will come back to that. And if we go further, then we go to the design. So here is a design firm, and every day I'm sitting here at my desk making awesome drawings and stuff like this. So this is the design part, and then if we look further, so this is the normal things we always do, and then we come to our construction. So here we are going to introduce our first Internet of Things ideas. So here we can get our first actual real-time data. So in the building process, while we are building, we are implementing sensors everywhere. So you can see if the strains are not overloaded if you build it, or if your crane is at the right position, so your frontman can check it on his iPad if everything is going okay. So the security and the safety of your building process can be made better. So, and if we then look at the bigger picture, So if we round everything up, we can see that we get a maintenance phase as well. We are going to build a BIM model, and this BIM model, the design boys are making the BIM model, and they are actually getting feed loops, information loops to your factory, because they want to know, okay, you have to produce this, and we have a loop to the construction, so the construction guys know what they have to do. And we're sending it in the cloud. And I call it a building hub, but you can call it whatever you want. Call it cloud, it doesn't matter. So we have these loops. And here the real closed loop lifecycle management kicks in. So this is what we always do now. This is our normal way of working. So we have our BIM model and everybody uses it. But actually CL2M adds sensors everywhere and will go back with all the information to a building hub, and then you get all these different life cycles from design to construction, construction back to design, construction back to factory, and so forth. So this is all those data is going back and forth. And then we have, and our micro world is advanced with a bridge. So that's the principle of closed loop lifecycle management. And now we know what it is. Why do we need it? Why do we want to use it? So there are a few things, but the biggest thing is we want to, and it's actually the third one, so it has, maybe I had to put it as first, is to pollute less, because we're in our world together, and we want to have this world a little bit longer. So it's nice to keep it like it is, or even better it. So how do we pollute less now? We can manufacture less because we get specific data. And if we get the feedback from the construction and we know, okay, this steel isn't good enough, or this concrete we have to change. If we know that and we get real-time data from that back, then we can look in the design and think, okay, I need different materials, so I can manufacture more specific. So I can say, no, I only need this, because I know out of my sensor data, this is gonna go a lifespan of 100 years or whatever. So that's why we need CL2M. And the fourth one I put in, it's to create safer environments, and that's more related to the construction building, so that we can monitor everything what happens in a real-time way. So we have our iPads or whatever, and we can see what is happening and where unsafe things are going to happen. So now we saw what CL2M is, why we need it. Yeah, but how do we get the data in our life cycle? How are we going to do that? And I have put on two methods to get it and two methods to distribute it. So actually the first one is RFID, radio frequency identification. Those are simple tags. It's the same as that you go into your building and you log in with your key card and you get access to your office. Those are cheap. There are practically no costs. The limitation of this method is the range. So for example, if I was inspecting something on my building site, then I could, as a contractor, go somewhere and just scan everything and see if it's okay or not. But then I would need to be physically there. So for some situations, that's really difficult. If you have a bridge of 100 meters high, you just can't come everywhere, obviously, and you can't always reach all sensors. And that's where the second part is coming in. LoRa is a long-range, low-power network. It's actually just a Wi-Fi, but really low in power consumption, and it can put data everywhere. And in some countries, like in the Netherlands, we have a LoRa about over all our country, so you could actually just put in and take go to your AT&T, for example, like in America, and then you can say, oh, I want to make use of the LoRa, and then you can use it. So that's the two ways you could get your data from your site back to the internet, to the cloud. And then it would be stored in a database. So you could set up your own database, and it could be as simple as Excel or Access. That's the most simple part, and I'm going to show you how you do that. Or you could use an SQL database of whatever kind you would like, and you could set it up on your own server or what you want. But the most advanced way now we have is to make use of a cloud solution. You can buy lots of IoT hubs, Internet of Things hubs, and then everything is in the cloud. So it's all automated, and you get it back. And I will show you how you can do that as well. So what sensors can we use in the maintenance phase? I'm not going to read all of these, but you can. The list is endless. You can do whatever you want with sensors nowadays. Today I'm going to look at displacement sensors in a tunnel, and we're going to look at steel tension bar in a bridge sensors. So, okay, why is it important? I mean, now we know what it is, why we need it, how we get our data. But why is it important to implement it in an early stage of our projects? So we need a framework. We want to know where to put our sensors, because, yeah, you can put sensors everywhere, but if you do that, then all of a sudden you don't know anymore. You get that much data, you don't know what you have to do anymore. Second part is you want to define what to improve. The one solution is, okay, we are going to do a lot of sensors, and then we get all the data, and then we see what we have to change. But the other approach is, I want to know, and I want to see what I have to improve, so I can define, okay, I want to know now which concrete I want to use. So then you can do that. There are cases that we have a lot of sensor data already available, so we could actually learn from that and build from that. So this is actually, if it's already implemented. The last one is IDs. This is in our BIM working ways, we need codes everywhere, or IDs, because that's the way stuff will get recognized what it is. So here in the design stage, we are going to state which idea is where. You want to do that very flexible, but you want to say now, okay, this is your ID, this is a sensor ID, and this is the same everywhere. So it's very important to know that you have to do this in your design phase. You want to do this in your design phase. So what do we want to do with our BIM model then? Because what are our BIM goals? We can state in our BIM execution plan what we want to do, what we want to do with our BIM model. So I want to see where stuff is. I want to say, okay, this sensor will go there. This sensor has these coordinates. It has to be placed there. So the contractor knows where he has to put the sensors in. I want to sort and separate. I want to search in my model. I want to search for my IDs. I want to know where it is. The third part is I want to see the real-time data. I want to click on something, and I want to see what actually the sensor is measuring, and I want to see those values come up in my BIM model. And the last part is I want to visualize my data. So I want to have easy tools. So I push a button and I see, oh, right, here it's not going as was planned, or here it's not anymore to the requirements we wanted to have. So that's the visual side of our BIM model. So then, now we know what we want to do in our BIM model. So now we are going to look at the steps, how to get there. And I myself use a lot of Civil3D, so I thought, oh, I'm going to do it in Civil3D. And then in Navisworks, and we're going to see what happens. So I'm going to show you a project, and I'm going to do it real time. So if anything goes wrong, then it's the computer. So we have this junction from a freeway, and it's really congested, so we have to change stuff about it. We're gonna destroy some, we're gonna build some new roads, but we're not gonna focus on that. We're gonna focus on a modular bridge, where we're going to look at the tension from the steel in it, from the pre-stressed parts, and we are going to look at a modular tunnel. Why modular? All the building blocks we are going to use are prefabricated and put in. So we have tunnel segments and we have bridge segments, and it's easy to put in. And in this way, we can easily put in IDs and allocate stuff. So how do we get there? What are the steps in civil? And after all this presentation, I'm going to do a drill, so don't fall asleep, please. So first, start a Vault project. We do all our work in Vault to have everything in one location. So we have our document management system, and then there we are going to state everything. And it's not entirely true, because our databases aren't in Vault, obviously. They are in the cloud. So, but all our engineering stuff is actually in Vault. So the second thing we are going to do is we are going to create subassemblies. And here we are, this is the first part where we already are going to say, okay, here has to be a sensor, and here I'm going to incorporate my ID. So this is actually the very first start. We are going to say, okay, here's an ID. And this idea is throughout the whole life cycle. If we did this, we're going to define actually, because this is how would I put it? This is a general subassembly, and then we're going to go to civil and say, okay, we are going to define the ideas actually where it has to be. We're going to create corridors, and then we're going to create solids and property data. And actually, the property data is the nicest thing we had in a long time. So we had that for a little bit, but now it's implemented so you can use it easily, use it out of the box, and can put in some data where you want it. So we can put in the metadata, and that's very important because there our ideas are getting tracked throughout the whole life cycle. So is this new? Yes and no. I mean, I think 60% of what we had was the same as we do every time. And maybe 30% is a little bit high, maybe it's lower, it's not really that advanced. And if we look at what we actually have to add to our actual design work, there are three things. So we have our real-time ID links we need, we have to have metadata of objects, and we have to have a cloud connection. It's not rocket science, actually. So now I'm going to show you, and I'm going back so I can show you the steps right away. So first, Vault. I have a little bit of a problem with Vault, that I can't reach it from here because I'm overseas and I'm in the Netherlands, so that's not... everybody who is only for Vault here, I'm sorry for that. Oh wait. So our first step is create a subassembly. So you could do this in Civil itself with standard subassemblies. But if you want to go advanced, then you need the subassembly composer, obviously. So I started, where is it? Here. I started to make a modular bridge. So I have my bridge parts. I added them here, and here I can build everything I want. And here we can see we have steel bars that will be pre-stressed and hold the whole bridge together because it's a modular bridge. And here we have to state which IDs we have to do. So actually here we have a lot of bars and barcodes and everything, and it is already filled in, but there are default values obviously, and we will fill them in Civil in a different way. So all of these parts then we're going to put into Civil. So if we go back to this, so we have made our subassemblies, and then we're going to Civil. And if we go to Civil, you will see a very not sexy model. I mean, this is not really pretty, but I don't care because everything is in 3D, and my BIM model, that's leading. So I'm not wanting to make drawings or anything. I just want to make a 3D model. So we will see in Navisworks that it's more pretty than this. But here I didn't focus on anything else than it being a nice 3D model. So if we look at our assemblies and we put it like here, we can see the same thing we had. Oh, let me change the scale a bit so you can read it more easily. Maybe a little bit more. So here my IDs are stated. So I put the IDs in, so we select our subassembly and we say, okay, I go to my properties, and here I have all my codes that I want to fill in. So here I can choose if I want the tension bar or not, and then I can say, okay, if I have this tension bar, what is my ID? And those ID are all synced to, so module 1 is 1 point and then the number of the bar it is in. So if I, for example, would take module 6 and put it here, then you would see this has only one steel segment, steel bar in it. So for all these modules, it's different. So if I remove these again. So then we are going to build our, and actually the bridge is under the tunnel, that's strange, right? So we have a bridge and we have our tunnel. And actually it's nothing different than a normal corridor. So if I would select this and I would look at them, at the properties, then it takes a while, actually. And then you can see here are all my modular parts. So it has a length. My parts are 20 meters in length. So my frequency is set to 20. So I have these modular parts, and everywhere the codes are in place. So that's actually the stuff we always do, right? We make a subassembly, we make a corridor, and then we build it. That's no biggie. But then we are going to say, okay, we go back to our, we have defined them, we have created the corridor, and then we're going to create the solids, and that's the fun part. So we're going to say, okay, I want to create the soliders, and I want all stations. And then it looks like the same as always, but then in our property data we can choose what we want to do. So here we will say, okay, I want my code name because my code name is my ID for my sensor. So this one, our code name, we are going to link in Navisworks. So we can see where the ID is and where the ID in our database is set in. And for the bridge I did it like this, and for the tunnel I will show you I did it a little bit differently because it's easier in the beginning, but it will be very hard if you change stuff in it, and then it's a lot of work. So actually if you build a corridor like this and you make your shape codes all your IDs, and you can take it with you to Navis. So the output, it's dynamic, so if every time you rebuild it's awesome, it works just fine. And you could actually change, if you think, oh no, I messed up my code, so you could change it actually. If you think, oh no, I changed this ID 110, it's not modular 1, but it has to be a different one. We could just say, oh no, I'm not 1.1, but 1.2 and so forth. But that's not different than we always do, right? So if we have this, that's the way you want it to do, but you could actually just state other things. So if for example, if I made my tunnel and I have this 3D solid and I don't want to put it in my code name or anything else, I could just add my own property data to it. So that's what I did here. So actually beneath here you can see I put in a real-time data sensor ID, and here I can just type in the sensor ID. And the dangerous part about this is if you do this and you rebuild your model and you do you change stuff, then it forgets what it is. So this is actually not the most advanced way, but it could be a good way to do things if you have normal solids or you don't have a corridor and you know it's not going to change anymore, or you know where it has to change and you change it yourself again. So here you can put any metadata in you want. So actually, that's the part of civil. It's not really that hard, I guess. So let me go through it. So we saw this. We saw that as well. So now we have our model in place. I mean, we have our design model in place. I'm not going to focus on how the other parts in the Navisworks model came. So we have a tunnel design, and we have our bridge design. We have all our IDs stated. So now we're going to look at how we get the real-time data in Navisworks. So we can use IoT services, or we can use Excel. I will show you Excel. It's the same principle with SQL databases. I will show you how you do it with SQL, but I can't do that live because then you will all see all my credentials for all my SQL databases, and that's not something I want to show you. So, and if you're crazy like me, maybe you could build your own sensor at home, and then you could put it in front of your window, and then you could count how much cars are coming by, and you could see it in your model. But you can just go to this website, and they will tell you how to build this. You can build packages there. You can buy packages there, and then you can build everything you want. So using IoT services, I myself use Microsoft Azure as yes, sure. Yes, sure.
Could you please develop a little bit about what you mean by sensor? I don't think it's a sensor.
Okay, the sensor. So the sensor is a device which measures stuff that is happening. So for example, if I would make a sensor, the same as that you walk through a door, and then you walk through the door and it's automatically opening, so that's your sensor. So if I walk there, the sensor will see, oh, there's someone coming, and it does something. And you have all those sensors for concrete. You can put sensors in concrete, and it measures how much water is still in the concrete, for example, stuff like that. So and you have sensors everywhere. How hot it is in your thermostat at home, that's your sensor. So you could, I mean, everything that can be measured, you can put a sensor on. So, does it
mean the sensor will read information during the construction and will feed it back to the
exactly.
cloud on the BIM model?
Exactly, yes. So IoT services, Internet of Things services, this is where our sensor data which is coming in is sent to. And I use Microsoft Azure, but you could use a lot of different services. And here is my hub, and you can see I have one device, and it measures the stuff, a lot of stuff. So it's a really easy interface. So here our data is coming in, and then in the same IoT hub we have our SQL databases. So here I have my database, and all the data that is coming in from the previous slide you saw is coming in my database, and then I could use it in Navis. So how is our Navisworks workflow? We need a database. I just showed you we need a database. We fill it. That's our first step. We need that. The second step is we need all our BIM objects. They have to be added through Vault because we're working with Vault, and then we have everything nice in place. And if we have that, the BIM objects, we have our IDs on our BIM objects. We know where everything is. We can connect it with our SQL connection strings. So we have a dynamic link to those objects. So if our database is updating in like a second interval, or a minute, or 10 minutes, or a day, or a week, it doesn't matter. This data will always be refreshed the same way. So it's a real-time link. And the fourth step is actually making the data stand out and put some visual styles to it, and we can see, okay, here is something happening, and here's something going wrong, actually. So now I'll show you in Navis. So we have a BIM model in Navis, and I put up a few window docs We have our Vault browser, so we can see everything is in our Vault. We have a normal selection tree, we have saved viewpoints, we have selection sets and search sets, properties, and our appearance profile. So first of all, we have to put all the data in. So we are, we're going bridge design, I guess. So here we can see it's a little bit prettier than in Civil, right? It's, I mean, it speaks more. We can see what it does. Actually, the existing terrain is from Infoworks and then put in here to Navis, just to make sure that everything is nicely in place. And then we put in the design, just added with our Vault browser in it. So actually, we have our second step, and our first step is our database. So how does our database actually look like? And I mean, this is Excel, and this is exactly the same as what we would see in an SQL database. It's just a list of all the things we have. Not everything is filled in yet, but here you can see, and we did two different methods. So we have one in real-time data. So here are my IDs. I put in myself, and here we can see our corridor shape information, the other IDs from a corridor, which is the more advanced way to do it. Those are all here. So we can look at those. Here, but yeah, if you look at this, you think, oh yes, awesome, my ID 2.1 is a tension measurement, and it has this value, and I don't know if it's good or not, and it's not really pretty to look at those lists. So we go back to our Navisworks, or actually we're going to look what our third step is. So the second step, we have all our BIM objects are in place. And then we want to put in our SQL connection. So how do we do that? We can do this globally. So we have here our data tools in Navisworks, and we can set it up for your user profile. But it's, yeah, maybe you have stuff you always do, but for my project it's always a little bit different. So actually what I mostly do is do it in the data tools from this file. So here you can see I have three links to databases, and the first is the IoT Navisworks Azure, which I will show you the selection string in the PowerPoint. And then it's exactly the same. The SQL string is a little bit different than the Excel one, but the rest is all exactly the same. So I have this IoT Navisworks Excel displacement is for our tunnel, and I have this Navisworks Excel tension for our bridge. And it's actually really easy to do. So if you go to edit, I don't know if you could read it, but you can download the PowerPoint after this, and it's in the handout as well. So what we here are actually saying is, okay, you have to search for the Excel where it is. And then you can say, okay, I know this Excel I want to have. And then you can state in your SQL string what you want to do. So it's relatively straightforward. Select where I want to select stuff from where. From my real time. So if we go into our Microsoft Excel, you can see here my tab is real time. So I have to match that so he knows where to find it. And I will state where. So he has to search at real time data. So he will look at all the data that is in real time data. And then if you read this, go to your Navisworks properties. Search for real-time data, and match the sensor ID. So he's going to match what is in the sensor ID between this real-time data and this real-time data. So and if we put this up, then we can just put in stuff like this and what we want to see in our Excel or not. So you can put them all in, or just a few, or you can do whatever you want. So now actually we set it up. So okay, and if I click now here and I go all to the right, I have a new tab. So in here my tab states what is in my Excel or in my SQL or in my database, wherever it is, in my IoT hub. So now you have this data, and it's actually, I forgot one thing. Let me add that. I mean, I now can see which ID it has, and I would like to know right away if my idea is right or not. So let's add that. Displacement, yes, edit. So actually we have to look what it's called. So we want to see our real-time data, right? And then we are going to put in here real-time data. And you could name it otherwise, so my field name has to be exactly the same as in Excel, because otherwise it won't find it. So, and then my display name, I could name it whatever I want, but I like real-time data, so I will just do that. And you saw it already pop up. So now if I select this, I just can see what ID 13 it is, real-time data 13. And if I go here, my real-time tab from the property data I get in from Civil, I can see, okay, it's ID 13. So it works. So this is actually our connection, and for SQL it's exactly the same, with a little bit of a twist with the SQL string. So now we have put it in, and we can look. Okay, we have our connection. So now we want to make it visual. So actually we have it visually sort of in our properties, but again, it's the same as in Excel. You don't want to go to each thing and click on it and go to your properties. Maybe your properties aren't open always, and then you have to look at it and think, okay, awesome, okay, this is it. So one of the first thing is you could make quick properties, so that if you hover above it, you can see what it actually is, and then you can put in whatever you want. You actually do this in your options and in your interface, quick properties, and your definitions. And it probably has to think, because he's looking at the Excel or at your database. So here you can state what you want to see if you hover over it. And then you could make it easier. But still, I mean, this is the same thing as that you click on it, you have to hover it. And I mean, in our tunnel, we have like stuff underneath it, right? Because if I hide this, I mean, there are things here, so I can't actually hover. It won't show actually. So that's not what we want, and we want a quick visual style of our data, if it's still in requirements or not. So how do we do this? We can actually do this with the appearance profiler, and I will show you how it looks, and then I'm going to tell you how to do it. So if we look at our tunnel here, we can go to our appearance profiler, and it's not really scripting, it's not really difficult. We can state some stuff. So I'm just going to run this, and then you can see what the effect is, and then I'm going to tell you how to do it. So now he's looking in our Excel database, he's searching for the data, and he's linking a visual style to it. So now you can see my tunnel is actually colored in. And for this example, I obviously rigged the data, so it is a pretty sort of rainbow. But here you can see, okay, what is actually happening. So in my list here, I have a displacement below 40 millimeters. That's green because we think it's okay. And then if the displacement is going up, then the color is getting more red. So actually here we probably have a problem. So the displacement is too big. We have to change something. Some things are there is something that's not right anymore. So this is a great way to just show you how what the data is, and this is, you can see obviously see right away where it's not good anymore. And for our bridge, it's a little bit different, but the principle is the same. So let's do this now. So we go and load our different appearance profile set. Load. So we say our tension critical values, and this is actually a bit simpler. Here I say, okay, is my critical value of tension reached, yes or no? And hide, make transparent my modular bridges, because otherwise I can't see it. So if I run this, it's looking again at the Excel, so it has to load a bit. And then you can see, okay, all my parts of my tunnel are see-through. And then I can see, oh, here is a problem with my tension, and here it isn't. So you could actually put whatever in what you want here, and then you can see what is critical or what isn't. So how to do this? Let me reset this. Load. Oh. So we can reset this. So actually it's pretty straightforward. What we have to do is we have to make search sets. So we are going to search all the objects who have a certain value from our data which we are putting in. So we're going to find items and we're going to our category. Oh, let me make that a little bit bigger. Condition value. Right. So actually here you see what you can find in your model. So we're going to look at our Excel displacement because I want to have the values he gets from my Excel. I want to color in, or I want to select first. I want to search that. So in here, our property, we can change what we want. So for our displacement, we have our we have a sense of value because we have to color it in, and our condition is or is below. You can do whatever you want. So if you want a value, and now it's not doing anything. So you think, oh, there is no data in it, but you just have to just first load it, and then is reading here as well the same values he can find in your databases. So here you can say, okay, all the values of 10 I want to select. So if I now do find all, he will search for all the objects who have that. And if we go below, you can see actually it selected all of these. So we're going to save this as a search set, not a selection set, because if we add some stuff with the same value, he searches for that as well. So if we would do a selection set, it's just a relatively stupid selection. So if we have that in place, we can do this for all the objects. And the only thing we have to do here in our appearance profiler is actually color them in by sets. So we say, okay, I have my coordinate shape ID, or I have my displacement. I will give it a color here beneath it, and then I will put it in, and then I can use it. I can save it everywhere I want, and you get and you always have this nice visual style you can use. So you could actually do a lot of stuff with this. So yeah, that's actually the last step. We make our data stand out, a visual. So now we can see in our model what is my central data, what is the value, is it critical or not. So that's actually pretty straightforward. So this we had. So how do we do a link? Yeah, it's not really good to read, I guess, but you can download the presentation. So the only thing different to actually SQL in the cloud is that this selection string is a little bit different. So there's just like a comma is different, and it's like really potato. So this actually brings an end to this presentation, and I only have one real recommendation. So I looked at Civil and Navisworks now, but I mean there are a lot of different softwares out there you would want to use this. First, we can think about, if we think about BIM, is Revit. So you could add the metadata there as well. It's no problem. It's like the same thing we do in Civil. In InfraWorks, we could do that as well. We can use custom schemes, and we can update those with the SQL database in the same way we do with the Navisworks. So we could actually, when we really start at the really beginning, we could do it in InfraWorks. We could do it in live, actually. So you could go through that in your VR, and you could look at those real-time sensors as well. And the last thing, and that's where I am really fond about, is in Forge. So you could put all your BIM models in your Forge platform, and you could there use it in the same way we just did it. So just add the SQL databases, but the Autodesk research team is actually doing Project Dasher. It's really amazing. You have to Google it and find it. It's really awesome. So they are really putting effort into this. So yeah, I mean, I showed you some simple steps in Civil and some simple steps in Navisworks, but we could actually do this through our whole software scheme. So, questions? Yes?
Do you see this as like evolving into some like single platform where you could do civil BIM, so how to use separate software?
Yes and no. I mean, ideally it would be awesome to have that, but I don't think in the near future it's going to happen because of all the different things. I mean, there is a lot of stuff happening with the common data environment in Forge and in the cloud from Autodesk. So, and that will be very open and wide. And if you look at those things, there are really a lot of softwares are plugging into that. So I don't think there is one solution who will fit all. But in your cloud solution, you would want to do that. So, yes and no. That answers your question?
Yeah.
Yes, okay. Yes.
The SQL database or
Yeah,
Excel
yeah.
data, it's linked to the BIM model and
Yeah.
separate
Yeah.
database, let's say.
Yeah.
And it's filled by different engineering departments, maybe. So how do you manage the linkage between this SQL database and the BIM model in terms of when the BIM model is updated several times with different departments?
Yes, yes. So that's why I brought in how important it is to have those ideas. So you have to have coordination about your ideas. So you have to have several persons or companies who are willing to adapt to one single ID framework, so that is used. So that's very important. Yes, so that's difficult to achieve, actually. Yes, but that's not an out-of-the-box solution for no, not yet.
Do you guys use large files inside Vault, say point cloud data, survey data kind of stuff?
Not a lot of point cloud data, but for the rest we use relatively large models. Yeah.
And so all of that is inside Vault, say the
Yeah.
gigabyte range for a single file.
Sorry.
The files that you got inside Vault, have you got say a single file that's about a gigabyte in range?
Yeah, no, we have it is in compartments, so it's a bunch of relatively. I mean, our biggest files are like 100 MB or something, not bigger than that. But then in chunks, it is in there. So yeah.
What's the purpose of linking BIM objects in the Vault?
In Vault.
And was there any, what did you did in Vault?
Yeah, I mean, you could do it every way you want. It doesn't matter, but we use Vault because there's a great solution to have all your information in a Vault. So actually, you could do it whatever you want. So the common data environment, which is coming up and is building up now, you could use that, or you could just use your C drive. Yes.
Vault isn't necessary for this process.
Not really. No. It's a nice to have, but it's not exactly needed. Yes, that's true.
What are some of the most powerful sensor types that you imagine in the operational phase? I'm imagining displacement on a bridge. I'm imagining temperature in a mechanical room. What's some of the ones that you believe are just going to be everywhere?
Seismic sensors. I mean, then you could predict what is happening, and you know, and you can see, okay, this is the actual limit, and then stuff breaks, and then you can design better bridges, for example. So I think that's a really big thing we would want to have. And otherwise, yeah, what you said, safety. Just if in building construction, if something, if the crane is holding it or not, stuff like that. So more the safety. Yeah, I think that's. I mean, we want to do better and we want to pollute less and stuff like that. But I think the safety is the quick win we can achieve right now, so that our buildings are safer. Yeah. Yeah.
Just linking with these two, same question.
Yeah.
Based on your experience and during the construction phase,
Yeah.
what was the best solution in terms of sensor that it's very famous that you use a lot?
Actually not. No, I mean, we put up this workflow and we didn't implement it till now. So, yeah, I can.
So even during construction,
Yeah.
and even during the pre-commissioning and after.
Yeah. So yeah, we just implemented this in our workflow. So we have to see what will happen if we actually implement it outside. So there are companies in the Netherlands who did this in the construction phase, and they were very positive about it. But we didn't do it ourselves yet, so that's coming. Yeah. So I can. Yeah.
So when you're sending data to Azure,
Yeah.
I'm assuming you're sending that from Vault. Is that correct? I'm not real sure how you
No,
get
no.
Vault metadata into the actual database.
So actually, I'm not putting metadata from our BIM to the Azure as of right now, but only the other way around. But you would want to do that, yes. So that's not actually now the workflow that we have, but that is what you want. So, yeah. So now it's only a one link to Navis and not back to Azure. But you could do that. I mean, you could export a CSV and then upload it, and then make it a time frame of uploading. So that could be, yeah.
What are your thoughts on actually who will own that lifecycle data going forward?
Sorry?
What are your thoughts on who will actually own that lifecycle data going forward?
That's a difficult one. The owner?
Well, again, if
Yeah.
you're doing works for governments or
Yeah.
things like that, I'm interested in actually thinking a little bit more about that as a business.
Yes, sure. Yeah, ideally the owner, because it's his building and it's his data. But we are not there yet, so that's a really difficult part, yes. So, yeah. The owner?
It seems like the savvy owner is thinking about making sure that in the contract, I want the data.
Yeah.
So, but maybe that's in all of our industries, the owner is a little bit behind.
Obviously, yes. Yes, sure, yeah. So we have a long way to go, that's true. But we're getting there.
So are you providing owner in your company when you say, I want to be your engineer, I want to be your partner, and we will arrange the language so that you get all the data?
Yes, obviously, yes. Yes.
So you're not really thinking about the owners, but actually it's how you can offer added value as part of your contract, which is what differentiates you from your competitors.
Obviously, that is one plus. I mean, the whole idea of it is that the whole life cycle is better about that. But why? I mean, if you have, if you can do it better than yourself, that's always a plus. Obviously, yes.
Do you know any owners that are really savvy and thinking about this? And they
Yeah,
succeed
there
next year?
are some construction companies who are doing it, but then only in construction. But the owners not really yet. No.
One part of challenging issues that the owner facing is the final interface that will manage the data. We don't have any mature one that they can manage the whole process.
That's true.
So, I mean, the process that we describe, it's very good.
Yeah.
It's amazing. But in terms of the owner, if he need to process several projects, he will not have, or do you recommend any interface like in terms of EDRMS or data management interface?
Yes, that
Go to
that is something you would want to have. And as I said before, the common data environment we are getting is actually doing that. So you get your visual side of it, and then you get your database and like, so you could look at them and you can see what is happening. So that's actually something we were working on. So that you saw the last bullet, the Forge one. There you can actually send it to your clients, and that's then there you could state where you have to look. So yeah, we are actually working on that. Yeah. So it's 5 minutes, I just heard. So if there aren't any questions anymore, I thank you for your time and have a great day.